Hello students, welcome to the lecture sessions of Mathematics 2. Up to last session, we have seen how to solve the first order higher degree differential equation by two methods, equation solvable for P and equation solvable for Y. Now, in today's session, we are going to use equation solvable for X. Okay, so we are today starting with, suppose if same as equation solvable for X. Suppose you have X is equal to some function of Y and P. This is equation number 1. So the method is same as we have done in solvable for Y. Here you have to differentiate with respect to Y. That will give you dx upon dy is equal to some function of y, p and dp by dy. Now dx by dy, that is nothing but it is 1 upon p, correct? So now if some capital F ypc is equal to 0 is the solution of equation 2, then eliminate P from 1 and 3 will give us general solution. Again, the same note will be there. If P is not able to eliminate, that means if P cannot be eliminated, can't be, in that case we have x is some function of P and y is some another function of P, and this is we have this which is a parametric solution of equation 1. Okay, same manner, if any factor in equation 2 doesn't have dp by dy, then we are not considering it. Okay, now we are going on to the example. Suppose you have given x is equal to y plus a log p. Okay, so here you have x is equal to y plus a log p. So differentiating with respect to y, both side, that will give you dx upon dy is equal to 1 plus a log as a derivative 1 upon into dp upon dy. Okay, but here see, you have dx by dy, that is nothing but is 1 upon p. So I am going to write this in a form of 1 upon p minus 1 is equal to a upon p dp by dy, and that will give you 1 minus p upon p is equal to a upon p dp by dy. So pp will be cancelled out, and writing in a variable separable form. So cross multiply and simplify, that will give you 1 minus p dy is equal to a dp. So integrating both sides, okay, but you cannot integrate in this manner. So you have dy is equal to a dp upon 1 minus p. Okay, so that will give you dy is equal to minus a upon p minus 1 dp. So integrating, that will give y is equal to minus a log p minus 1 plus c. Now see, this is the value of y, and from this one you cannot find the p, correct? So we are writing this as it is, and we are going to substitute this in equation 1. So putting the value of y in equation 1, that will give you, putting the value of y in equation 1, we have x is equal to, x is equal to y plus, so y is minus a log p minus 1 plus c plus a log p. That means a log p upon p minus 1 plus c. So equation 2 and 3. So equation 2 and 3 are parametric solutions of equation 1. Okay, now we are going on to one another example. Here you have yp square plus 2px minus y is equal to 0. Now see, here what we have y and p both, y and x both. So but here you have singleton x. So I am going to write this as 2px is equal to y minus yp square, and that will give you x is equal to y upon 2p minus yp upon 2. Now differentiate with respect to y. That will give you dx upon dy is equal to, here you have to apply u by v rule. So first denominator as it is, derivative of numerator minus numerator as it is, derivative of denominator is 2 dp by dy divided by 4p square minus 1 by 2 constant, and this is your 1 upon p. Here you have to apply product rule, 1 by 2 into y dp by dy plus p, correct? So if you are separate these terms, then you will have 1 upon p is equal to 2p upon 4p square, that is 1 upon 2p, minus y upon 2p square dp by dy minus y by 2 dp by dy minus p by 2. Now taking this opposite side, terms of dp by dy, and taking the terms of p this side, that will give you, see here dp by dy and y common out, so y dp by dy common, okay, and you will have 1 upon p square 2p square plus 1 upon 2. So we can common out 1 upon 2 also, is equal to 1 upon 2p minus 1 upon p minus p by 2. 1 upon, that will be a minus 1 upon 2p minus p by 2. So taking LCM 2p, and that will give you minus common out, So 1 upon 2p plus p by 2. So I am going to write down this in a form of y dp upon dy into the bracket 1 upon 2p square plus 1 upon 2 is equal to, here I am going to take minus 1 upon p into 1 upon 2p square plus 1 upon 2. So this can be written as y dp by dy plus 1 upon p into 1 by 2 common 1 upon p square plus 1 is equal to 0. So this term does not have any constant, does not have any dp by dy. So you have dp by dy plus 1 upon p is equal to 0. So simplifying this one, that will give you y dp upon dy is equal to minus 1 upon p. So p dp is equal to minus dy upon y. And that integrating both sides, that will give you p square by 2 is equal to minus log y plus c. Okay, or you can write down that c by 2, so 2 can be cancelled out, so p square is equal to c minus 2 log y, and therefore p is equal to plus or minus under root c minus 2 log y. So you have the value of p, so we are going to substitute this value here, and that will give you the value of that will give you the solution in a form of x. So here putting the value in equation 1 we have, okay, so what we are going to do, we are going to write this in a form of p square is equal to c minus 2 log y. First we are going to write the equation y into p square, y into p square plus 2px minus y is equal to 0. So y into p square is c minus 2 log x plus 2x into under root of c minus 2 log x, and that's why you have, this is the solution. Or if you have to eliminate under root, then take all these terms opposite side. So y into c minus 2 log x minus 1 is equal to minus 2x under root c minus 2 log x, and square both sides, that will give y square c minus 2 log x minus 1 whole square is equal to 4x square into c minus 2 log x. So this is the answer. Okay. So this is the method to solve the equation solvable for x. Now these are the topics which we have covered in today's session. If you have any doubt or any query regarding these topics, then please feel free to contact me. Thank you so much.